So in this picture, we've got then an example of a non-renewable power plant generating electricity. And notice then we've got these 6 numbers down at the bottom, kind of a legend for the picture. And we can start with number 1 being fuel is burned to make heat. In this case, we have what's most likely coal. Remember from the previous presentation that coal is usually crushed into a fine powder before it's routed into the furnace. So that's what number 1 is. Fuel is burned to make heat, and this fuel is coal. The second thing that we see, the second bullet, says water is heated, turning it into steam. And notice that we've got then within the furnace a series of pipes. Liquid water comes in on one side, is routed through the pipes, and the pipes are situated literally within the flames of the furnace. And so these pipes acquire the furnace's heat, and the water inside the pipe then acquires the pipe's heat. So energy is transferred from the fuel via combustion into the pipes and then into the water. When the water does this, it changes state. It turns from liquid into vapor, and we call this steam. So out from the other side, and this is number 3, the steam travels through a steam line. So out of the boiler then comes steam, and that steam is then routed to a steam turbine. The steam turbine's job, remember from the previous presentation, is to spin. That's the only thing it does. So steam comes in on one side, it's high pressure, and it then induces spin in the turbine. Notice also number 4, the steam turns a turbine which spins a shaft. The shaft, remember, is connected to number 5, the generator. And number 5 down here says, inside the generator, the shaft spins wires producing electricity. And we see then we have a detail here of a generator. This is the same detail that I used on the previous presentation. And we have then, of course, copper coils spinning in relation to these magnets. When this happens, then you get electricity generated. And number 6 explains then that it first goes through what's called a switchyard. In a switchyard, the voltage of the electricity is stepped up. That is, it's increased. And the reason for that is because oftentimes power plants need to send their electricity over many, many miles, sometimes hundreds and hundreds of miles. And the best way to do this is with high voltage, because that then eliminates some of these things called line losses. So the switchyard is where that increase in voltage happens, and then from there it's sent to consumers. Notice also in this diagram, although it's not mentioned in the key down here, that there is beneath the turbine a condenser. So we have steam coming in on one side, the turbine spinning, and then right beneath it we have a condenser. The condenser literally condenses the steam back into water. Now, a good question would be, well, if the turbine runs on steam, why in the world would you turn it back into water in order to then boil it all over again? Well, engineers have figured out that this is in fact the most efficient way in order to induce the best and most efficient spin in a turbine. By condensing the steam into a liquid, you create a vacuum, and that vacuum helps the turbine spin more efficiently than if there was just steam coming in on one side and steam going out on the other. Now, if we contrast this picture with the next one, this is an example of renewable electricity generation. And in this case, we have wind. We could have used many other ones, but wind is a handy one here. Notice that at the very front, we have the rotor hub and a couple blades listed here. Usually turbines have 3 blades. And this wind turbine, that turbine word is important because remember, a turbine's job is to spin. All right, so these blades capture the wind, and then a spin is induced. Notice here we've got from the turbine a shaft, and that shaft is connected to then a generator. Before it's connected to the generator, however, it always goes through what's called a gearbox. And this gearbox takes the low speed of the spinning turbine shaft and then steps it up to an increased speed. And remember, more speed to your spinning shaft means more voltage. And higher voltage means you can move that electricity down the wires better than if you had low voltage. So inside then this turbine's housing, you have then a generator, and although we can't see inside this generator, we can know from the previous presentations that they're simply copper coils and magnets situated in a certain way so that when one spins in relation to another, they are in very close proximity to capture all the magnetic flux lines and induce all those electrons to start moving through the copper.